This video is for your Poperties Organizer. When we're looking at some of the properties, these are some that you should have been taught before, so I'm just going to do a quick review on these. For the community property, this is when the order of values does not matter. This would be things like addition and also multiplication. If you have A plus B, it's going to be B plus A. 5 plus 3 is the same as 3 plus 5. And the same is true for the multiplication. You can multiply A times B or B times A, and you're going to get the same answer. Just like 6 times negative 2 or negative 2 times 6 gives you all the same answers. That's the commutative property. The associative property is when grouping of values does not matter. So that's going to look like this. It doesn't matter whether you add A and B first and then add C, or if you add B and C first and then add A. It's going to be the same. That's that grouping, the parentheses. Whether you group A and B together times C, or A times the grouping of B and C, you're still going to get the same answer. Now the identity property, that's when things stay the same. It doesn't matter what you do, they're going to be the same value in the end as they are in the beginning. If you add 0 to A, you still get A. Just like 5 plus 0 is still 5. A times 1 is A, or like 5 times 1 is still 5. That's the identity property. It stays the same. The next one here is the inverse property. With the inverse property, using opposites to cancel a value. If you add 8 and negative 8, you're going to get 0. And when you've got like a fraction, if you take 4/5 times its reciprocal, remember reciprocal is just when we flip the fraction upside down. So you got 4/5 times 5/4. You end up with 1. That is the inverse property, doing the opposite to the number to cancel the value. You might also remember the zero product property. Multiplying by 0 always equals 0. Well, that's pretty easy, right? 17 times 0 equals 0. And if you have the quantity of 5x minus 1 and multiply it by 0, you're still going to get 0. That's the zero product property. Zero product. Product is multiplication. And the last one that you probably have heard before is the distributive property. Distributive property is when you're multiplying a value to an expression inside parentheses. So you've got the parentheses and you're multiplying it by the number outside. So we have a 2 outside the parentheses. You're going to take the 2 times the x and multiply it to get the 2x. And then you're going to take the 2 times 7, which is going to give you the 14. So down here again on number 2, you're going to do the same. Negative 6 times x, which is going to give you a negative 6x. Then you're going to take negative 6 times, make sure you look at that negative sign out front because it's subtraction. Remember, that's the same as adding a negative. So you've got negative 6 times a negative 3, which is going to give you a positive 18. That's the distributive property. Now looking at some of the new ones here, the newbies, is you might not have heard of the reflexive property before. A value will always equal itself. In other words, A is going to always equal A. If we're looking at some examples, it would be something like 16 equals 16. It's like a mirror, it's the same. 7x equals 7x. And 4y squared equals 4y squared. That's the reflexive property. Now the next newbie here is the symmetric property. If A equals B, then B equals A. With the symmetric property, if x equals 3, then 3 equals x. If 5x equals 30, then 30 equals 5x. And our last newbie here is our transitive property. What's that saying is that if you have A equal to B, and you also have B equal to C, then that must mean that A is also equal to C. So in this example, if we have 4 plus 3, we know that's equal to 7. And if 7 equals the square root of 49, then we know that also 4 plus 3 is equal to the square root of 49, which 4 plus 3, like I said, is 7, and the square root of 49 is 7. So 7 equals 7, which is the identity property. But that proves that the transitive property is true. Now our last little section here is called the closure property. A set is closed under an operation if the operation always produces an element of the same set. If an element outside the set is produced, then the operation is not closed. I know that sounds really complicated, but it really isn't. So we're just going to look at some of these examples and figure out if the statements are true or false. If false, we're going to give a counterexample. What makes it false? Integers are closed under multiplication. So that's just basically saying if you multiply an integer by an integer, and if you remember, an integer could be positive or negative. So no matter what two numbers you multiply together, 2 times negative 3 is negative 6, 4 times 3 is 12, you're still going to get an integer as an answer. That means it's closed. If you multiply two integers together, you're still going to get an integer. That's an example of something that's true. Now what about natural numbers? Natural numbers are closed under subtraction. Now if you remember, we're talking about natural numbers. If you remember natural numbers, that means they are only positive numbers. So can you subtract two positive numbers and get a negative? Because that would be false. That closed means if you subtract two positive numbers, natural numbers, you're going to still get a natural number, such as 4 minus 2 gives you 2. But what if we flip that around? What if we have 2 minus 4? If we have 2 minus 4, we now get negative 2. That is not a natural number because remember, natural numbers are only going to be your positive numbers. So that's false, and that's an example of why it's not closed. Let's look at example 3. Even numbers are closed under addition, meaning if you add two even numbers, are you always going to get an even number? So you got 4 plus 2 is 6. 6 plus 4 is 10. 8 plus 4 is 12. See, you always end up with an even number as an answer. That means it's closed. You have even numbers, you end up with an even number. So that's going to be true. How about irrational numbers are closed under division? So that's saying if you divide an irrational number by an irrational number, you're going to always get an irrational number. Like if you have the square root of 10 divided by the square root of 5, you're going to end up getting a decimal that goes on and on and on forever, which is an irrational number. But what if you take something like pi and divide it by pi? That's two irrational numbers. If you take pi divided by pi, it's just like any time you do something like 5 divided by 5 or 4 divided by 4. Whenever you take a number divided by itself, you're going to get 1. So that means this is false, because I just proved that I can divide two irrational numbers and end up with a rational number, not an irrational. So go ahead, take this sheet and work on that sheet that says warm-ups at the top. And when you get finished, make sure your name is on it and get it turned into the drawer that says first.